The paper of the day is the complete story of joins in HyPer. SQL has evolved into an almost fully orthogonal query language that allows arbitrarily deep nested subqueries in nearly all parts of the query in order to avoid recursive evaluation strategies which incur unbearable, that is order of n square runtime. We need an extended relational algebra to translate such subqueries into non-standard join operators. This paper concentrates on the non-standard join operations beyond the classical textbook inner joins, outer joins, and anti-semi-joins. Their implementations in HyPer were covered in previous publications, which the paper refers to. In this paper, they cover the new join operators, mark join and single join at both levels. At the logical level, they show that the translation reordering possibilities in order to effectively optimize the resulting query plans. At the physical level, they describe hash-based and block-nested loop implementations of these new joins. Based on their database system, HyPer, they describe a blueprint for the complete query translation and optimization pipeline. The practical need for the advanced join operators is proven by an analysis of the two well-known TPC-H and TPC-DS benchmarks, which revealed that all variants were actually used in these query sets. Paper compared two systems. First, HyPer, which implements the techniques and algorithms described in this paper, and PostgreSQL, which implements the mutual recursion strategy. When comparing the query execution times of the two systems, it is, however, hard to disentangle the effects, that is, query engine performance, join types, and optimizations using complex benchmark queries. They therefore show some simple example queries and discuss how these queries are evaluated and how will they perform. Now, looking at the contributions, based on the HyPer database systems, author described a blueprint for the complete query translation and optimization pipeline for join queries. As SQL has evolved into an almost fully orthogonal query language that allows arbitrarily nested subqueries in nearly all parts of the query, there is a practical need for advanced join operators to avoid recursive evaluation with an unbearable order of n square complexity. The practical need for the advanced join operators was proven by an analysis of the two well-known TPC-H and TPC-DS benchmarks, which revealed that all join variants discussed in this paper are actually used in these query sets. The paper covered the logical query translation and optimization as well as the physical algorithmic implementation of these join operators. Here they concentrated on the hash join and block nested loop join variants, which are predominantly used in HyPer's current query engine. For practical hands-on evaluation, the interested readers are invited to experiment with their online demo at hyper-db.de that provides a graphical visualization of the step-by-step query translation and the optimization phases. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 8 out of 10 on readability. With 20 pages long, it scores 8 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is high, so it gets 8 out of 10 on each with overall PS score of 8 out of 10.